Everyone, so welcome to this quick intro about recursion, and you might have seen a lot of memes about it that's somewhat like this one, and you would just have wondered that why is it all about repeating and what does it mean. Just kidding, I know that you just want to crack the best company, and I do it too. So let's hope that we can learn recursion so that we can work better with dynamic programming. Okay, so that aside, what is recursion? So recursion is like, when you were a child and you were in a car and you would ask your father, have you reached? He would say no. And then you would ask again, have we reached? He would say no. And then he would ask again, have we reached? And finally he would say yes. So now you're out of the loop and you've got the desired response. So effectively, recursion does focus on repeating a particular function until we get the desired response. But the only difference is that we use a smaller input. Right, so it's the same. Just imagine that this is the road, this is your home, and this is your destination. Okay, you asked your dad, have we reached first here? Right, so the distance was, let's say, 100 kilometers. So here you asked after 10 kilometers, so the distance now becomes 90 kilometers. So your input has reduced. Then you asked here, let's say around 50 kilometers from this, so total 60 kilometers. So now what is the distance left? 40 kilometers, and so the distance again has reduced. So every time we use a smaller input for the same function to get the desired output. So that is something like recursion, but not exactly. Recursion is when a function calls itself to solve a smaller version of the same problem. Right, so the problem was the same. When do we reach? You're just getting a shorter distance, right? So you're calling the same function, on a smaller version of the same problem. That is the definition of recursion. I'm very sorry for my handwriting. Okay. Now, whenever you're working on anything related to recursion, you have to think of two things: the base case and the recursive case. Let's have a look. So what is the base case? Base case is when to stop. Okay, it basically shows when do you stop. And what is the recursive case? So recursive case is when you are reusing the function. Right, so it's like basically it's the function that you define. That's the recursive case. So right, so here is a code, and this code will only give you a countdown. Okay, only give you a countdown. So what is the countdown? Countdown is 5, 4, 3, 2, 1. Right, so what is the base case here? When will you stop? Whenever your n equals to 0. That is when you will return blast off. Right, or so what does this tells you? This tells you the action you're supposed to do. And then this is the recursive case where you are using a smaller input. So right, so you started off with n. So here, if you notice, you started off with n here, and now you're using the same with n minus 1. So what will happen here? Let's see. Let's make a stack. So first what you do, you pull f of 5. Right? So you have f of 5. Now you have f of 5, and since it does not satisfy, n is equal to 5, right? N is equal to 5, so it does not fulfill here. What you have to do, you will print n. So this will output 5. But then you also have to put f is equal to 4. You have automatically called f is equal to 4 here. Then again, when n is equal to 4, it will not satisfy. So we are just going to print 4. After that we come here. Then again, this would call f is equal to 3. This is not also 0. So then this will print 3, and then this would call f is equal to 2. This will print 2. Then it would call f is equal to 1. This would print 1. Then f is equal to f of 1 is going to call f of 0, and then we are going to print blast off. Right. So this is actually a very classic problem in Python. So where you have to count numbers from 1 to n or n to 1. So if you had to count the numbers from 1 to n, what change would you make in the code to count it from 1 to n? It's simple. So what you would do, so currently only thing separating is this part. If you put this here, then f is equal to 5 would just call f is equal to 4. F is equal to 4 would count f is equal to 3. F will 3 count f2, f1, and then f0. Then it will give off blast off. Then once this is given, then f of 1 will be executed to print the n, right? And then you will print 2. So that's how we get 1, 2, 3, 4, 5. So actually it's easier to get the countdown printed than it is to print it in the right order using recursion. Now let's talk about something very important, factorial. But what is factorial? So if you would remember, let's give a breather. 5 factorial is basically 5 into 4 into 3 into 2 into 1, right? But recursion logic, you have to use a base case and you have to build a recursive case, right? So what is the main thing? So for base case, I want to find a similarity, right? Every function has to converge on the base case, no matter if it's 5 factorial, even if it's 6 factorial, then it has to be, right? Even if it is 7 factorial, then it has to be, okay, wait, I find a pattern. The pattern is this. The base case in all of these would end on 1. So the similarity is that all end on 1. They can start however they want, right? And now what is the recursive case in all of this that I realized is that 7 factorial is just 7 into 6 factorial. 6 factorial is just 6 into 5 factorial. 5 factorial is just 5 into 4 factorial. So this is the simplest recursive case that I have found. So when I'm coding, the first thing I'm going to build is this. Let's use that. So this is my base case that whenever n is equal to 1, I'm going to return 1. And then what is my recursive case? 2 factorial is just 2 into 1, right? So n factorial is just equal to n into n minus 1 factorial, right? So this is my recursive case. Simple. Now let's discuss Fibonacci. What is Fibonacci? So the Fibonacci sequence is actually a very popular sequence in nature. It has been observed in flower petals. It has been observed in pine cones. It has been observed even in galaxy spirals. So it's a very famous thing, and I hope you guys read about it, because I'm not going to discuss it in depth, but how it occurs in nature. But the crux is that the Fibonacci sequence is this: 0, 1, 1, and then 2, and then 3, and then 5, and then 8, and then 13, and then 21, and then 24, and so on. But this doesn't make sense, right? Except these two numbers. Okay, so these two numbers are fixed. After that, we just add the previous number. So 0 plus 1 is equal to 1. 1 plus 1 is equal to 2. 1 plus 2 is equal to 3. 2 plus 3 is equal to 5. 3 plus 5 is equal to 8. Then 8 plus 13 is equal to 21. 13 plus 20, and 13 plus 21 is equal to 34. So this is what the Fibonacci sequence is. So your task right now is to identify the two things that we have to do in any recursion question, that is find the base case and the recursive case. I'll wait for 3 seconds. 1, 2, 3. You can pause the video for however long you like, but it's very evident that the base case is this, right? Because this is going to be constant in every other question, and the recursive case is just adding this number, so n, right? You just have to add n minus 1, that is 13, n minus 2. Does that make sense? Let's review it again. I think the red is too blinding. So here, so here there was 8, right? Now I'm doing 8. So 13 plus 21 is giving us 34. So how am I getting f of n? How am I getting f of n? I'm getting f of n as f of n minus 1 plus f of n minus 2. That is giving me f of n. So when I look at the code, it also makes the same sense. And what is that? that this is our base case. If n is equal to 0, I have to return 0. If n is equal to 1, I have to return 1. Now the recursive cases, for example, my n is 2. Okay, now what will happen is that we for I in range 8, print f of I is equal to Fibonacci I. Okay, so now what will happen in this is that my range, if I change this to 2, right, what will happen is I will get Fibonacci 2. It's not 0, it's not 1, so I am going to return Fibonacci 2 minus 1 plus Fibonacci 2 minus 2. This will be Fibonacci 1, right? This will give me 1. And then similarly, this is Fibonacci 0, right, here. So this will give me 0. So 1 plus 0 is equal to 1, right? So now how will I get? I will get f is 0, f is 1, and then f of 2 is also equal to 1. Does that make sense? Similarly, if I want to do this all for f is equal to 3 or f is equal to 4 or f is equal to 5, it will be the same. With this, I hope you have a clear understanding of the meme that we were discussing. I don't often repeat myself, but when I do, I use recursion. Well, there are a lot of other memes, and I hope we can discuss them in the next.